Bharti, welcome Bharti.
Yeah, good evening, all of you. At the outset, I give all the glory to the Almighty for all that He has done in my life. So I want to start the session. So my profession is into CAD/CAM, 2D modeling, 3D modeling, manufacturing, and 3D printing. This is what I am doing for the organization where I am put up. So next slide, please. So today we are going to discuss about the points I have mentioned. That is, what are the types of 3D printing and how to convert 2D into 3D, and what about the shape and strength of the products if suppose it's 3D printed, and what are the problems and troubleshooting, and the choice of materials. Then some of the interesting topics like 3D printed post office recently launched in Bangalore that we are going to see little bit in detail, and other applications and future scope of the 3D printing, and 4D printing is there, and what about that, and some of the video clips on printing. This we are going to discuss today. Next slide, please. So this is a history of 3D printing. So usually we type resume, we take 2D printing, right? For submitting our resumes or any kind of official letters, approval copies, whatever it is we are typing and taking. So it's like only images that you will be able to read the images or read the letters or speech letters. 3D printing is nothing but we are adding one more dimension, that is 2 dimension plus another dimension like thickness or height, whatever we consider. So that is 3D printing. So in 1984, Charles Chuck Hell, he who developed the first 3D printer and he named it as a stereolithography. So that is why till date we are using stereolithography, that is STL is a translator for converting the image from any other high-end engineering software to analysis software. So for meshing the things. And in the 1990s, other companies also developed 3D printers. And in 2005, Z Corp, they launched the first high definition color 3D printer. Whatever it is, wherever color adds, that will be quite interesting, right? So color 3D printer has been developed in 2005. So nowadays in India, everywhere we are able to see 3D printers, and I'll tell in detail about 3D printers and its technology behind. Next slide, please. See, these are the types of 3D printing. So there are types depends on the applications. See, that is stereolithography. Here it is mentioned SLA. This is a type. Okay, and stereolithography STL means it's a format, because the Charles Chuck Hull, he who found the 3D printing, that is why till date we are using that format as a translator. And digital light processing DLP is there, selective laser sintering is there, fuse deposition modeling, what we are using in CPET here in CPET Mysore. Other CPET center they have various methods, and the selective laser melting SLM method is there, and DMLS is there, electron beam melting, and multi-jet fusion polyjet. So these are the types and etc. So many methods are there. So in this, if suppose you want to print only polymers, then you need to prefer like FDM or SLS or STL or SLA like that. If you want to print metal printing, like you can go for like SLS, selective laser sintering also it's possible, electron beam melting it is possible, selective laser melting is there, and even polyjetting, it's a combination of polymer and metal and other different types of like composite materials that is possible with the polyjet. So for example, your tabletop is there or some kind of paperweight is there. If it is made up of single material, it won't look that attractive, right? Suppose inside one small kind of plant is there, some kind of bubbles there, some kind of fish is swimming here and there. So these kind of combo can be printed and at one platform, that is polyjet method. So it's quite expensive, but you can have very like magical kind of products can be made out of polyjet. And metal printing. So metal printing means like, first I'll tell you, 3D printing means we can call it as additive manufacturing, AMP additive manufacturing technology. Okay, manufacturing technology means we are able to produce parts by manufacturing by means of subtracting the material. If suppose I want to make a nut, okay, simple product. So my workpiece will be a cylinder, like a cylindrical piece. So I have to subtract the material so that I will get a nut or bolt or whatever it is, right? That is a regular manufacturing method, maybe of conventional methods or non-conventional manufacturing methods like CNC milling, lathe, or regular lathe machineries. In 3D printing, we are adding material. We are not at all using workpiece initially. Our platform is empty. We are going to add material. We are going to construct it by adding material. That is why it is called additive manufacturing technology, AMT method. Okay, so in this, all these types are like that. In that, one beautiful method is that is SLS, selective laser sintering, okay, or selective laser melting. See, in this, we are going to like solidify the resin. The resin will be there like ink. Okay, in those days we used to use hero pen or any other ink pen. Inside we have to fill ink, right? Then we are going to write it. Like that, in this also, some kind of resin will be there in different colors. So whatever kind of color you want to have, like the plastic gears or mixy jars cup or whatever it is. So you can solidify the resin by layer method. Finally, you are going to release a component out of the your 3D printer. So that is why it is called the 3D printing, that is additive manufacturing technology. Next slide, please. Yes, now we are able to see images. This I can call it as photographies, right? You are able to see Taj Mahal and some kind of humans, family they are standing, and some kind of flowers is there. So some of you are asking me questions. I have only 2D images, 2D pictures, say 2D picture of my father, grandfather, or like world wonders. Whether it can be converted as a 3D? Obviously, yes. But the thing is, you should have a scanner, 360-degree scanner, which is already scanned our image. Suppose I want to have my statue as a keychain or kind of things, right? My photo is there, like a clicking camera, I can have my photo. Using that photograph, you cannot have a 3D printed part, okay? Before using that photograph, using that scanner, I have to stand inside the like the scanner room. So it will scan 360-degree angle, it will scan all my body, okay? So that the cloud of points will be connected, all the curves, in terms of curves or points by any means, it will give you the image, okay? Whatever color is there. Then you can go for directly printing our image. Like that only Taj Mahal, no need of printing even inside, which is possible, but a Taj Mahal or like a Twin Tower or like a or China, Great Wall of China, whatever it is, that can be constructed using 3D printer like a model. Okay, it's really quite amazing things using 3D printer. For that, you may ask where I cannot carry the scanner near to the Taj Mahal. Not like that. So many kind of like famous places it's been already scanned like using satellite, and there is a website. So certain images are available in that website. So you can download the application and using your 3D printer, you can print like any type of churches, temples, or statues, whatever, like Buddha statues. It is possible. So this how we can convert 2D to 3D conversion. Next slide, please. See, this is a simple product. What I involved, this is my project using 3D printer. Sometimes back, I think in the year 2018, Dr. Prajot Sodhi is a senior program coordinator. He is serving for UNDP New Delhi. He just visited our secret Sonipat. Previously, I was working there. So he came there. He just shared his view because he is into service. He asked me, oh, Madam, like these rack pickers are more in India. So in that, varieties of age groups are there. So small heights and stout fellows and tall fellows are there. So they have to pick the racks, pick the wastage from the grounds, and they are collecting and they are getting their wages. So when they are bending per day, at least 60 to 100 times they have to bend to collect the waste from the ground. So I want you to develop a tool. It's of course available in the market, but he discussed this with me. So it has to be adjustable height, and the labor, they should not bend and pick the dust or pick plastic waste. So you please design such a component so that it would be useful for the nation, like that he said. Then I thought, okay, we can make this one. Then I called my team and we have discussed and we started designing this part. This is quite interesting. There are 14 polymer parts. It has been made out of ABS, okay, ABS and nylon, both material. And between each stem only metal pipes we purchased and some kind of spring or some kind of nuts and bolts we purchased, some few metal parts. Otherwise, we just assemble it. And top one, you would able to find a trigger. If you press it, it will click. You just press and leave it. The dust, whatever they collected, it will not fall out of the jar. Okay, it's a like kind of a reversible mechanism we made it. The existing one is not reversible mechanism. Every time they have to press and release like this. So here in this case, little bit different mechanism we just introduced. And adjustable pipe, adjustable spring also we just made it. So he felt very happy. The day one he explained about this product, only he shared his view. But we released the product in 5 days. On fifth day, I will hand over the project to him. That means I'm able to convert one's views into a real product, and its assembly also is there. It's not easy because GDT plays major role in this. Okay, assembly is there and it is accessible and it is in working condition. So in 5 days, we are able to deliver the product, means it's a wonder of 3D printing technology. If the same product, if I might have preferred the regular or traditional manufacturing method, I will tell you how many days it will take. For designing, okay, designing is same in 3D printer or any other thing, it will take say 3 days, okay, and I have to go for manufacturing using CAM, computer aided engineering manufacturing. I have to call each and every component, then I have to go for manufacturing. Since the product is made up of polymer or plastic, I have to go for mold. Okay, so for mold, I need to develop tool for making each and every part. In this, you are able to see so many parts, around 14 parts are there. So I need to develop 14 molds. So 14 molds in tool room. So I have to select the material, metals like EN18, EN28 grade, carbon steel, tool steel, mild steel, whatever it is as per the available data. I have to prepare a tool for that. So for manufacturing, it will take at least 2 months, 2 to 3 months it will take because parts are many. After that, I have to go for choice of material. I am talking about a regular manufacturing method. Then okay, material has been selected. Then I have to go for selection of injection molding machine which is suitable for making these parts. In a single injection molding machine, I cannot make all the parts at a time. Only one part in a machine. So like that, if you count it, it will take another 1 month. Okay, 1 or 2 months. So almost 3 to 4 months it will take to release this component if I prefer regular injection molding machine method. Okay, so you just imagine time and labor cost and the cost of the machine and machining time. So all the things you put together, this will be very expensive, and the customer has to wait for a very long duration. After 5th month only he will receive the component, and we don't know whether it will work as per our view or not. Okay, that is possible. You can go for troubleshooting in computer aided engineering analysis software like Mold K'96 or ANSYS or Master, whatever it is you know well. So using that, we can come to the somewhat conclusion at that end itself. But instead of waiting for 5 months, where is 5 months and where is 5 days, right? You see the huge difference, and there is no material wastage also. Directly you are purchasing material. If it is a FDM method, this thing has been used FDM method, that is fused deposition modeling. It's like a wire, like this wire. So we are going to paste it like layer by layer by layer. So first, I have to develop a model. These 14 parts have been designed using NX or CATIA or Creo, whatever software it is, and we are validating the design at that design stage itself. Okay, and assembly point of view also we can simulate the assembly and we can check it. That's not that difficult using softwares. Then we are going for a FDM method, and the choice of material is ABS, acrylonitrile butadiene or styrene or nylon. Using the wires, we are going to make it, construct it like layer by layer by layer. For that, we need to slice the design in design stage itself using STL translator. In NX, I have constructed a model, or CATIA I have constructed, or Creo, whatever it is. While translating the material into this 3D printing, I need to mesh the model. Before meshing, I need to slice it. For that, the translator called STL. So after that, it's easy to make it. Just connect the machine, you go home, in 45 minutes, you will have your product. That is the beauty of 3D printing technology. Next slide, please. You see this one. He is Dr. Prabjot Sodhi, Senior Program Coordinator, who is seated in New Delhi, UNDP, and he has shown this product to our Honorable Prime Minister also. So he has appreciated our product. Then further, I could not able to reach that level. So I just got transferred. Then I came here. I could not able to take up this project further. But in future, I may take this. So actually, he requested 5 lakhs parts of this, so that CPET also will generate a good revenue. So in this point, we are working out right now. Yeah, next slide, please, James. You see this one. This is one small 3D printer FDM method. This machine name is method. Okay, it's a FDM technology, fused deposition modeling. So here I have developed this model. First diagram you see, there is a part called grip. Okay, this is being used in helicopter. So helicopter is having power effect. So over pole there is a pad main rotor head. So in that pole the wings are connected, maybe of 3 wings or 4 wings, depends on the load of the helicopter or size of the persons who are going to travel in that helicopter. So for connecting the wings with the pole, we are using this grip. So using this grip, it may be of 34 in numbers or 64 in numbers, depends on the size of the wings. Okay, it's a small part only. It is called grip. So this grip is made up of BSIS 96 steel grade. It is been given by Hindustan Aeronautical Limited, Bangalore. So they asked us to produce this part, both machine also as well as plastic. So we are going to replace metal into plastic. That also CPET is doing. So this has been machined using CNC milling. We have machined this part, and the material what they supplied, which is not available in the regular market, they used to supply the material. So we have machinery supplied. And one more thing is also the arm cam droop restrainer. That is also a part of helicopter. So this all helps to hover the helicopter. So this one we have replaced it with the polyether ether ketone, PEEK material, plastic material. So the PEEK is suitable plastic material for replacing BSIS 96 steel grade material. So we cannot replace. I can call it as converting metal to plastic. That is a useful technical word. Otherwise, we can call it as replacing the metal into plastic. Suppose the chair I am seated, it's of wood and metal. If the chair is able to carry my load, my weight may be of 55 kgs or 60 kgs. If the chair weight may be of 5 to 6 kgs. The same chair I am replacing to the plastic material, maybe of polypropylene or polypropylene material. The chair weight would be around only 400 grams. Even my children, they can carry from one room to other room, even they can carry to the terrace. But where they cannot carry this chair, right? But the same chair is accommodating my weight also, children weight also. That is the beautiful characteristic of polymer material, that is strength to weight ratio. Strength to weight ratio is very good in polymer. That is why in this world, everywhere you are able to see 90% of plastic material. Okay, and the same material, you see this one here, the grip has been replaced with polyether ether ketone. This material can be used in 3D printer. Okay, so using these PEEK material wires, we produce this product. But before using PEEK, we have used polylactic acid, PLA and PVA, polyvinyl acid, polyvinyl alcohol and polylactic acid. Polylactic acid, you are able to understand lactic acid. It's a biodegradable material. Okay, so polylactic acid material, we have developed this product for R&D purpose, and polyvinyl alcohol, PVA, we have used as a supporting material. Why we are using supporting material means, whatever image we are constructing, you cannot construct only that model. You need to have some kind of support systems. This support has to be solved later. We have to dissolve it so that you can release the product. So it's very simple. Supporting material will be wherever hole is there, wherever gap is there. So the support material will be there, like polyvinyl acid, as I said. So you just dip in water, it will just get dissolved. That's it. Otherwise, there is a separate curing unit is there. If you put that product in that curing unit, in few minutes it will be dissolved. Otherwise, regular water, you just dip it, it will take few hours, then it will dissolve, you can release the product outside. Then you can do any other R&D work, any other development, any other mistake, whatever you want to add it, you can add later stage. Again, you repeat the model. Again, you repeat it with different material, or you just roll back to the design and change some kind of design parameters. Again, you can print it. So this is how you can reduce the time. I think 180, 1 divided by 80. Okay, so quickly you can release the product. When I'm able to release the product within 45 minutes to the customer, he would be happy. Nowadays, we are preferring online shopping platforms, right? Instead of traveling to shops and purchasing dress and wearing, checking, no need. You just pick the dress through online shop. Within 3 hours, if it is being delivered, we are happy. Same like that. When the product is being delivered to the customer in a day, definitely he will not say no. Okay. Yeah. Next slide, please. You see this one. This is, I already shared this. This is in these two beautiful things are there. First one, you are able to see a red colorful image that has been constructed in SolidWorks. Okay, one of my CAD engineer, I guided him. He developed this model in SolidWorks. Okay, in this some 7 to 8 parts are there. It is a collapsible stool, collapsible chair, I can say. You can fold it, you put in your laptop bag, backpack bag, you can carry anywhere. This weight is not even 300 grams. And right side, you are able to see the one. This is real chair. Okay, the beautiful thing is we manufacture using machining method and we manufacture using 3D printing method. Okay, so manufacturing, as I said, it took time. In this, mold is not involved. Directly we purchased big plastic blocks and we just machined it using CNC VMC, vertical milling machine. We just machined it. And other part, 3D printing. So around 7 to 8 parts are there. Using 3D printing, we used ABS because ABS is having good strength and it can withstand temperature also. So using ABS material, we have developed this part using 3D printer. So around 7-8 parts are there. And 3D printer also, there are varieties of ranges and depends on the size of the machine. You can prefer big size parts you need to develop or small parts to be developed. So accordingly, you can select the 3D printer choices. Next slide, please. Size and strength. Some of my clients, they asked, 3D printed parts and traditionally manufactured parts, there are difference. Then how we can face the challenge? Of course, it's there. 3D printed parts are also having good strength, but 80% strength it is having comparing with the traditionally manufactured part, machined parts or molded parts. Why? Because in 3D printer, it is being constructed layer by layer. One layer, again it will sweep. Then another layer, it will sweep. Other layer, it will sweep. And finally, the product will not have that, what you say, matte finish or gloss finish. For that, we have to go for secondary operation by applying some kind of diamond paste or whatever it is, so that the layer won't be visible. Due to that only, the strength of the 3D printed parts are 80% comparing with the traditionally manufactured parts. That's it. Otherwise, it's very good. And very thin wall thickness. It is possible to produce with 3D printing, but it will collapse, right? It will not stay stable. That is why we don't prefer very thin wall thickness for a 3D printing. So usually the advisable thickness is 1 mm to 2 mm. It is recommended so that the part will be stable. Next slide, please. Problems and solutions. Yes, there are more problems, but here I want to discuss only one problem, that is warping. If suppose other problems like how it is happening, if suppose nozzle is not set properly, if nozzle is little bit got shaken, or it is not aligned properly, means definitely material go here and there, right? You will not have a fine finished product. That is one problem. Other problem, if the bed, okay, the platform, if it is not straight, if it is there is a small kind of inclination like a 0.01, then also you will have a problem. Your component will have it won't have proper dimension. Other than this, warping, because while we are constructing the plastic wires or plastic granules or metal granules, it has to be molten, then only you will get the product. Okay, then only it will be constructed. Then after constructing, it will be solidified immediately. We are not going to wait for cooling, right? So due to that, only warping happens. Okay, even in the regular molded plastic parts also, we can expect this kind of warping because of differential in cooling. That is why while machining the cooling circuit, I am talking about traditional manufacturing method. In the mold parts, when you are machining the cooling circuits, you have to balance the cooling circuit that should be uniform. So entire component should get cooled at a time. So uniform cooling is always advisable to avoid this kind of warping problem. In this case, here we are not going to have cooling channels, right? We are going to construct a model and dipping in the solution like water or whatever it is. So definitely when sudden cooling happens, it is called quenching, right? So warping happens. Warping takes place. To avoid it, you can increase the temperature in the bed, or while releasing it, you can add temperature. So something like that, but by balancing, you can avoid warping. Okay, next slide, please. You see this one. This is my favorite insect. This is called the fireflies. Minkambuchi they'll tell. In Tamil, Minkambuchi or Minmini Puchi will tell, right? So this Minmini Puchi, during night times, daytime also it gives light, but it won't be that visible, that eye catching. But during night time, it gives us light. How come it is happening? Because barium sulfide or zinc sulfide, when it is born, this insect is having in its body the zinc sulfide. So while flying, suddenly it will just sprinkle the zinc sulfide. That is why it is glowing. So natural material, it's giving light. The same material is being used in 3D printing. Okay, and one disadvantage in 3D printing is you cannot use 2 lakhs of materials. The regular traditional manufacturing method, you can go for 2 lakhs of plastic and polymer material. But in 3D printing, now R&D work is going on. Around 250 materials only permitted to use it. So you may ask one question, if I use XY material, what will happen? The nozzle will not work out or it will get stopped. So like that. So the research work is still going on. But this zinc sulfide is being used, and for this another material is a barium sulfide. So zinc sulfate means it's a fertilizer. Okay, but zinc sulfide means it's a like lightning purpose. It glows for road signals. When you're traveling over highways, when you're driving, you're able to see the signal boards and even the road dividers also, right? You're able to see red color indicators, yellow color or green color. So these all the things are zinc coating only, zinc sulfide coating, and some kind of advertisement. There you can find some kind of reflectors or dances also. The experts, while they are dancing, performing dancing on the stage, they will turn off all the lights, but they in their dresses, only skeleton image will it will look like dancing. That is nothing but this zinc sulfide or barium sulfide coating only. Okay, this material also being used in 3D printer. Next slide, please. You see this one. the second one. So this is the icon Mr. Balaji used for making this brochure. And yes, it is true. If a person lost his hand or ears or any of his body features or parts, so that can be developed using 3D printing and it can be fit on human bodies. Okay, like first one you are able to see, that is sap material, super absorbent polymer. So what is super absorbent polymer? That is potassium polyacrylate, or one more alternate material is that sodium polyacrylate. These two materials can absorb water in a vast quantity. And further you cannot squeeze it. Okay, so that it will look very beautiful. It will attract, you can keep it on desktop, you can keep it on a tabletop for decorative materials. Same material for making like human organs, like it's artificial hand, artificial foot, nails, right? They are using this sap material only in 3D printing, and you just soak it in a water and it will blow, right? It will just become puff, so that you will have your shape like fingers, hand, like that. Previously, it will be like a flat only. Then when you dip it in the water, it will become like a cylinder kind, or whatever shape we want. Like rose, you want to make it for your tabletop, it will be in flat form when you are using sap material. Then you can have your real rose. It will glow also and it will be transparent. It's very attractive one. And the other one is you are able to see 3D printed telephoto lens. In that also reflectors, that is zinc sulfide coating is there. And the next picture, you're able to see the sportsman helmet. You can ask, I want to use at a time 4-5 materials and different colors. Yes, it is possible. When you are having 4-5 nozzles, 3 to 4 nozzles at a time, each nozzle is supply separate material, like violet color in one nozzle, while red color in another nozzle, yellow. It's possible to have different color and even different material also for making a product. And the third one is toy. Of course, in this metal is there, plastic is there, varieties of material and varieties of color also possible. And the fourth image you are able to see, that is polyhema contact soft lens. So we are using specs in glass. Okay, nowadays it's been replaced by plastic, no doubt. Polycarbonate is an alternate material for wearing specs because it is having very good transparency. Otherwise, you can use for polyether PMMA, polymethyl methacrylate. It is having the highest transparency out of all polymer groups. PMMA, but the thing is, PMMA or PC, it is hard. If once you shape, it will become static, right? So the person who is using for contact lens, you will find it difficult. Use it. So 3D printing, they have replaced that PC and PMMA to polyhema. Polyhema means polyhydroxyethyl methacrylate, which is also like sap material. That is super absorbent polymer. Dip in water, it will become soft. So the person who is wearing that contact lens, so they will not find irritating, or they will not find that something is there in their eyes. And in that they can write also like attractive words like I love you, heart symbol. See, these are youngsters. So this is also possible. When you are designing the things, you can have some kind of symbols and you can print it. So, and in that different colors also there. If you are wearing green color dress, you can have a green color polyhema contact lens. So like the red color lens, you can have violet color lens. See, this is all highly fashionable, right? Aesthetic point of view. It's very beautiful and wonders of 3D printing technology. Next slide, please. Choice of material. As I said, already I have discussed in detail. So in this, plastics. Under plastic, we are using polylactic acid. It's a biodegradable polymer. And acrylonitrile butadiene styrene. The system what I am using, the mouse what I am using, and the keyboard what I am using. This is all ABS material only. The same material is being used in 3D printing also. I can print my keyboard. I can print if suppose one key is missed. I don't need to wait for a mold and manufacturing production injection molding machine. I don't require. I'll just design my key, whatever I last say is that key missed. I will print in my lab itself. So that is the beauty of 3D print. Morning I missed my key. In half an hour I will have my key back. Okay. And Polyvinyl alcohol, as I said, PVA, and you might have heard about PVC, polyvinyl chloride, that is for pipelines. Since it is able to withstand the sunlight temperature, we are using polyvinyl chloride for overtank pipes. If it is an underground pipeline, you don't need to go for polyvinyl chloride material. You can go for a polyethylene HDPE pipe, PE pipe. Okay, and polyamide nylon groups. This material is also a choice of 3D printing. You can use alumide, aluminum powder, and resins. Resins is coming under thermoset material like teeth. Okay, our teeth can be replaced in. This is the beautiful technology in 3D printing. Okay, even I am also having one 3D printed half tooth. When I was eating some kind of hard material, half tooth got broken. So 3D printed tooth I am using, that is made up of resin only. They will measure the dimension and they will just print the tooth shape, whatever it is, and they will just paste it and fix it. Okay, this is not beauty. And metals, you can use metals also like the stainless steel, bronze, even gold, ornaments. They are making for using 3D printing. They are making very beautiful, complicated design which is not possible in regular traditional molding method. And even paper also can be used, concrete, even food, biscuits, bread, and all the things can be using 3D printing. You can have 3D printed chocolates, 3D printed biscuits, 3D printed cups, all the things. And as I said, water absorbing plastics, what I was discussing. Okay, this is the beauty of 3D printer. And reflector like the zinc sulfide, as I said, barium sulfide can be used. And the stem cells is a really wonder of 3D printing. Suppose anybody is lost their ear due to accident, finger, or any part, or heart valves, or kidney. These can be developed in 3D printing. This is called bioprinting. This bioprinting is called 4D printing because it is having its life. Okay, so what they'll do, stem cells will be developed. If suppose a person lost a small portion of his finger, okay, they will collect their cells and they will make it grow in a very sophisticated laboratory. It will take some 8 days or 12 days like that. And then using the stem cells, they will print their lost finger. They will print their ears, whatever it is. That is going on now. In India, they are making it. Okay, that is the beauty of 3D printing. Next slide, please. Yeah, material highlights. Don't need to fear for these slides. Okay. Antero 800Na, Antero, Altum, Resin, PPSF, FDM, PC, ASA, ABS, DRAN, PLA, FDM, ABS. This is cunning word of materials. This is cunning technology of business people. Who is going to supply your 3D printer? They want you to be their permanent customer so that we should not buy material from outside. We have to buy material from them. So they supply, madam, these are the materials only you can use for this 3D printer, like methods, whatever it is. So that when materials get over, I cannot buy this from other side, right? I have to approach them only. It's a kind of business technique, but it is nothing but antero means it is a peak. Okay, polyether ether ketone, but they decode it as a antero 800Na. We are thinking that is something else. The peak what I used for replacing that grip of pad main rotor head, helicopter pad main rotor head grip and pad main rotor heads arm cam group resting. Same material, they are coding as antero. It's nothing else, peak material. The thing is, the secret we have to find it. Even next one is antero 840 means some kind of filler. Okay, Altum 1010, it's also peak only and it's a resin and Altum resin is there. Then next is PPSF, that is polysulfones, polypropylene sulfone, and FDM nylon 6. FDM you forget, nylon, it is there available in the market. You don't need to depend the person who supplied the 3D printer. And nylon CF10 means nylon carbon filler 10%. That is the interpreting of this material. And nylon 12. Okay, these grades and groups are available in the market. And nylon 12 CF means carbon fill. Okay, 12. PC means polycarbonate, like contact lens or even bulletproof. Polycarbonate can be used as a bulletproof, and four-wheeler mirrors can be used using polycarbonate. And PC ISO, this is different type of additives. PC and ABS, it's a blend, polycarbonate, acrylonitrile butadiene styrene. So combo of these two, you will have a wonderful product. And ASA is nothing but a acrylonitrile styrene acrylate. It's also transparent material. Like we are writing using pen, right? Yes, this pen is there, right? This is like polystyrene or sand material. Transparent is there. Like that, ASA also having the transparency by nature. Next is ABS, acrylonitrile butadiene styrene. They have added ESD7TM. It's all only cunning words. You can use directly ABS material. ABS M30TM, CF again, carbon filled 10%, and ABS M30. Okay, and Diran TM, this is also ABS group only. Diran is also ABS, and PLA is a polylactic acid. It's a biodegradable material. And TPU means a toughened polyurethane. It's a thermoset material, like tooth, like solenoid valves. These can be used using TPU. And ABS M30I. This is also again acrylonitrile butadiene styrene. Nothing else. When they are changing its names, we are thinking that, oh my God, this is what kind of material we cannot afford from the other side. Nothing like that. We can purchase even ABS directly without carbon fill also. We can use it 3D printer. But only thing is, it has to meet the proper application of the product. That's the end use has to be met. That's all. Otherwise, we have no botheration at all. Next slide, please.
Barathi, just to give you a heads up on time.
Yeah.
We are at 7:45. It's going to be 7:50 right now.
Yeah.
So you want to plan your presentation from now on.
Yeah, sure. Yes.
No hurry. So we are focused listening to you, but no hurry. I'm just keeping you checked on the timing right now. That's what I'm doing.
Okay. Yes, fine. Thank you. Thanks. So now it is a metal printing. Why metal printing is needed? See, everywhere you cannot have only the part made up of polymer. Okay, maybe nut, bones, springs. These are all of metals. So for making dies, see, as I said, the traditional manufacturing method, if I want to go for larger volume of production, like I want to have 1 lakh pieces, then 3D printer will not work out because it's a smaller volume of production. It is suitable because it's expensive. Otherwise, if I need to have 2 lakhs of bottle caps, 5 lakhs of bottle caps, then you can go for a traditional manufacturing method. There you have to develop mold, no, like pore and cavity, whatever it is. No need. That mold also directly you can print it using 3D printing. That is what it says. So you don't need to go for milling, drilling and all. No need. The sequence of operation, you forget it. Directly, you just design the mold using NX, using cryo or SolidWorks, you print it. Your mold is ready. You don't need to wait for a regular manufacturing. That is what this says. Okay, so in this also some standard materials also they have given, like stainless steel, aluminum, extra. Next slide, please. See, this is a quite interesting one. 3D printed post office. So this 3D printed post office is launched in Bangalore this year only, 18th of August. They have launched this one. So built up area is 1021 square feet, and I think they took 43 days, 43 to 45 days. So L&T only took place. It's nothing but they used special grade concrete. It's also cement, sand, silica sand, something. It's a special grade material so that it will stick together. So they used robotics and 3D printers, that nozzle, whatever I said, they just printed in 43 days. They just made it. It's a wonder of 3D printing technology. Otherwise, for constructing house, for constructing one small kind of room, it will take at least 3 months, right? 3 months, 4 months. So in like one and a half months, they made it. Okay, so that is the beauty of 3D printing technology. They have very big nozzle and big robotics. Using that one, they constructed this one. However, we are going to see the video of this. Next slide, please. You can have a video on this. It's really interesting how they constructed it. See this one. Same technology, layer by layer method. It's not like a bulk method. You are able to see the layers. Instead of 6 to 8 months, they made it in 43 days.
This city presents always a new picture of India. The new picture that you saw today in terms of this 3D printed post office building, that's the spirit of India today.
Next slide, please. Is it not interesting? The 3D printed house. This is 3D printed house. This also we can have a video of this. It's also quite interesting. The world's first 3D printed house completed just in 45 days in China. Even in India also it is there. IIT Delhi, IIT Chennai, they have also constructed one house. So something like that only. It's also quite interesting. In 45 days, they constructed their own
Chennai
house.
was IIT Madras.
Yeah.
IIT Madras was the first to build an house.
Yes.
Twista.
Yes. That video I have not brought it. So just I brought it this for it's looking attractive. You can have a look over this. Yes, you can play the video of this. Next slide, please.
A video, no? Barathi, this does not have a video, right? So we move forward.
Yes. Next slide, please. Yeah, you can see this one. This is for our information only. It's a Guinness World Record holder. This one is the largest 3D printed object. It's the Oak Ridge National Laboratory. See how big it is. So entire campus they 3D printed. Okay. So this is the beauty of 3D printing technology. They also use the same special grade concrete. Okay. And the finishing also looking good. Next slide, please. See this one 3D printed car. So the car they named it as a Starty. So they just displayed in Chicago exhibition. Okay. So they just constructed this car in 44 hours. Entire parts, like very few parts only metals, like nut bolts, like that only. Other rest of the parts are totally 3D printed in 44 hours, not days. 44 hours they release their product and he has shown also by driving. So it's the beauty of 3D printing technology. Next slide, please. This is the application of 3D printing. So where and all 3D printing plays? It plays a major role in drones, robotics, automotive, industrial products, white goods, even food and human. Okay, human body parts, replacing of human body parts. So application is vast in 3D printing. Next slide, please. Yeah, this is 3D printed food. How beautiful it is. Even assemble the product, I forgot to tell. Assembly also, you don't need to assemble it. Making individual product, including assembly itself directly you can 3D print it. The assembly also activates. So that is a beauty. And in this, you can see the chocolates of human face, some kind of heart kind, some kind of mixture of like composite kind of buns or cakes. 3D printed cake. How beautiful it is. Very beautiful artist. We made this cake. So using 3D printing.
You had something that you have made at home. So
yes. Yeah, sure. 3D printing tea cup is there. So after drinking tea, I can eat the cup. I want to show this. This has been developed in our center only. Nothing but like bun is there, no? Bun and bread, rusk. We call it as rusk. That material is being used for making this.
Can you show it closer to the camera, please, Barathi? Yeah.
Yes. So in this cup, now itself, I'll just pour some hot tea or coffee. Okay. So I can have it in 2 minutes. It can withstand for 2 minutes. If it is more hot, it can withstand 2 minutes. If it is less hot, it can withstand 3 minutes also. Say I poured this. I'll drink this and I will eat this cup also. So like that. That is a 3D printed, I can say, eatable cups. It's the beauty of this. At the end of this session, I will have this cup also. I will not leave this. Yeah, it smells good because elaichi flavor has been added. Yeah. Next is, you are able to see future scope of 3D printing technology. Of course, I am telling you, in future there is no tool room, no production. Directly 3D printer only, all over world they are going to adopt it because of time. It saves 90% of time of manufacturing. So future scope is product prototyping. It's very simple in 3D printing. Additive manufacturing, as I said, AMT, and rare parts replacement. If suppose you want to replace your name, which is possible. Automotive prototyping and fraud prevention means like ATM card and credit cards that can be prevented because immediately it can produce, right? You don't need to wait. Customizable solutions. If suppose I want to give gift for my dear ones or friends, I want to make their add their name in that, or I want to make their face as an image. It's a customized gifts, right? So that is possible with 3D printing. Manufacturing and logistic, like reaching the customer in few minutes, few hours. So that is possible, and lower production cost, of course, because other machinery is not required, right? Apparel printing, wedding apparel on the NC that one lady is wearing. Even dresses also being printed in 3D printing. Medicines, healthcare applications, yes, and aircraft components we have discussed in detail. Musical keyboards, if any parts like strings or any kind of buttons, if it is broken, then you don't need to wait, you don't run here and there. You can have it, make it using your 3D printer itself, and parts in space and human organs and more. Next slide, please. Yeah, future scope of printing. Says supply chain resilience. It's possible only with 3D printing technology. If suppose operational disruptions, in terms of operational disruption, it can be withstand only with 3D printing technology. So that ability of this 3D printing technology to withstand like pandemic situation, like any kind of forbidden strike, no need to bother because under one roof in 3D printing, I don't need to depend on a vendors. I don't need to depend on a milling machinist. I don't depend on a production engineer, right? In 3D printer, I don't need to depend on anybody else. Make it and deliver the product to the customer directly. And design software and education, dental, digital marketing, metal printing, composite printing, automation, competitive, logistic. Yes. So these are there is no doubt the future scope is there for 3D printing. It's not there in future. Tool room will be closed. Production unit will be closed. Only 3D printing will be there. Maybe in another 10 years. Now we are importing 3D printers from USA or other countries like Italy, Norway. In India also they started assembling. Now we are going to assemble in our country itself, in their country, respective country, we can have our 3D printer. But the thing is, choice of material still R&D is going on. Instead of 250, it may go up to 2 lakhs also. Next slide, please. 4D printing. As I said, the bioprinting is called 4D printing. That is, 3D printed part is static. That is, it will reach the shape. You cannot change the shape, right? 4D printing, while printing itself, they will add some kind of shape changing wonders, so that when you leave the component, it will roll back and it will become like a ball. It will become like what to say, like a close or open like a lotus, something like that. That is called 4D printing. That is also possible. So it's also wonder of 4D printing technology. Next slide, please. This is shape marking system. You can have a video of a 4D printing. So how it's being, the shape is being changed. We can have a look. I think this is bioprinting. Human ear they are printing. They have developed the cells from the particular human and they are making it. Or some kind of gel. Let us see what is it. They are adding 4th dimension. 3rd dimension is height or thickness. In this, they are adding 4th dimension like shape marking. think you are seeing how it is changing its shape, right? Like jellyfish or whatever. That is 4D printing. That's it. One more dimension we are adding. I think that's all. I think next slide, please. Yeah, one more video is quite interesting. That Israel Prime Minister Benjamin Netanyahu, he is tasting the 3D printed food. Let us have a look because I enjoyed this video. I want you to.
תעשייתית שפיתחנו, שמיועדת להחליף משחטה. לשאלתך לפני כן, פה אנחנו טוענים את המדפסת הזו בתאי גזע, שאנחנו יודעים למעל לשריר ולשומן, והיא יודעת להדפיס טונות ביום.
טונות?
טונות של בשר מתורבת ביום. זה רק לשם ההמחשה, אתה תוכל לבחור את הסטייק שלך, והמדפסת תתחיל לשחרר סטייקים בקצב תעשייתי. סיריליון, אני לא יודע אם אתה אוהב יותר שומן או פחות שומן. באמצע. view order, slide to print. ופה בעצם המדפסת מתחילה לייצר סטייקים. סטייקים, הייחודיות פה היא שתאי הגזע נשארים חיים אחרי שהם מודפסים. סטייק יהיה מוכן בסביב הדקה.
דקה?
דקה. השלב פה הוא שווה ערך לשלב שבו הפרה נולדת בעצם. הפרה לוקח 2 עד שהיא נשחטת, היא מזהמת את העולם בתהליך. פה זה תהליך שהוא הרבה יותר קצר.
בלי שטח, בלי מים ובלי
בלי
צואה.
שטח, בלי מים, בלי חתימה פחמנית.
בלי פלטות,
בלי פלטות ובלי כלום.
איפה הסטייק?
הסטייק עכשיו מודפס, ועכשיו אנחנו נעבור
זה המקדונלדס של העתיד.
כן, כן, זה המקדונלדס, זו הקצבייה והמשחטה של העתיד.
פאסט פוד.
וההפתעה פה בעצם, אנחנו משיקים היום גם את המדפסת הזו, שהיא סמי תעשייתית. ובואו נעבור למדפסת השנייה, שזה השקה העולמית שלנו, שמדפיסה דג. פה זו מדפסת שמדפיסה מוצר שהוא מוכן לטיגון, מה שנקרא ready to cook. מכיל תאים אמיתיים, אנחנו מדפיסים בו בעצם פילה לוקוס. אין עוד חברה שיודעת לעשות דבר כזה. מכיל תאים אמיתיים, כ3 דקות להדפסה. לוקוס עם טקסטורה מורכבת. עכשיו אני אסגור אותה ונראה לכם כבר את זה מוכן. תן לה להדפיס, ככה זה נראה. ואנחנו נטעם את זה עוד רגע. פילה לוקוס מתורבת, שהודפס מבלי בעצם להשתמש בדג עצמו.
זה מוכן, אפשר.
פעם ראשונה בעולם שדבר כזה קורה.
אני אומר ככה, עכשיו מה, טוב,
אפשר להמשיך, זה טעים.
Even that food taste also good, he said. Yeah. Thank you one and all. And thank you, Mr. Balaji. Thank you, Mr. James. Thank you, Mr. Rishi. And who encouraged and motivated.
No, Mr. Too much Mr. does not suit. Thank you very much, Bharti. So I will think the session. I think you are able to compact a lot of content within an hour. Extremely good. What I would recommend, Bharti, is to go to the comment section. So there are very interesting questions that's coming in. So,
okay, sure,
so I'll read it out for you so that you can answer each questions. Because last time when I did the mistake of ignoring a few questions. So which is the feedback that came to me. So this time I'm going to go by questions, right?
Yeah, sure, Balaji.
I'm going to skip the first question that I had asked. So I'm going to skip that. So Prem is asking, at what stage do we do load testing or strength testing in 3D printing? How does 3D model change thickness, etc., based on material to be used? Plastic, polymer, or metal. When we have to design for a certain load condition. For example, in a garbage pickup, what is the maximum load the user can pick? Let's say the design criteria was for picking 2 kgs. How does one go about modeling to meet that condition?
Okay, that is the product to be tested actually. Okay, so in our testing laboratory, we can go for testing that how much, see, that rack picker, how much it can open, the jaw is there, like movable jaw, like this. So how much it is able to open, that much it can carry plastic bags, only plastic bag or paper cups. That's it. It can go up to even 2 kgs also. But to check the strength of that, you can have a certificate. We can go for testing using our equipments in testing laboratory.
The question here, I think, Bharti, is at what stage do you do the testing?
Immediately before releasing the product. For R&D purpose, we don't carry out such testing. When we are going to use it, like, okay, when we are going to supply to the customer, before that, we need to carry out the testing. Then only the product is quality assured to release the market. Without that, we will not release it, we will not sell it. It will not reach to the...
You may want to come in if a question is clear, if I've read the question correctly. So you may want to come in if you want to add something.
Yeah. Thanks, Balaji. Hey, thanks, Balaji. That was good. The question more was, every time the challenge with 3D printing is that you will have to test it for every product you build it.
Yes.
Compared to a traditional manufacturing.
Yeah, even traditional manufactured plastic product also, it has to be tested. See, there are standards, right? Suppose, for example, plastic pipes are there, underground water line pipes are there, above ground pipes are there. There you will find some blue kind of indicator. That means water pipeline. If there is no blue, means it's like a sewage pipeline, like that. Further, some standards are there. See, you take your water bottle, ABA. Water bottle is made up of PET, polyethylene terephthalate. We should not say plastic bottle. You have to tell PET bottle, polyethylene terephthalate bottle. In that, you will find one standard, IS like 14543. That is the standard. That means under that standard, what all the testing has to be done for that bottle, it has to be tested in our laboratory. It may take 1 day, 2 day time also. Like right from material identification test, MFI, multiplow index test, tensile test, compressed test, weathering test. All the tests will be carried to meet that particular standard. Then only we will still quality assurance. Yes.
Okay, thank you.
Even in the traditional manufacturing, right, Prem, when they manufacture any plastic parts, they do the prototypes first. And those prototypes goes under all the stress and strain and whatever analysis you want to do from a strength perspective. And then only they will start for the critical manufacturing. So typically even in 3D printer, you have to do this testing, consider first parts as
yes. See, even, either 3D printer or traditionally manufactured.
And for prototype parts, I think 3D printer is one of the... It's a huge market for prototyping. And I think...
No, prototyping is not essential for all products. Okay, when we are talking about sophisticated product like tooth has to be, you can have prototype. And if the volume of production is very less, then we can go for a prototyping method. When we are going for larger volume of production, you don't need to go for prototype. If the product is very sensitive or sophisticated, or GDT plays major role in that, or if it is being used for aerospace application or in satellite, then only we will go for prototyping. Otherwise, not, it's unnecessary wastage of money, right? Expenditure will be more. Not required.
Typically for any car products, right? When you, from all your cup holders inside your car or to your other components which goes on the interior parts of your car and everything.
Yeah.
For the first batch of a new model, they always do a prototyping.
Yes. For
and that's a very big market.
Yes.
Yeah, it's a big
that
market.
Is true.
In,
yes. Even two-wheeler also, bike, bullet, you will have small kind of model, you know. Every showroom you will have your prototyping. It will catch our eyes. And in that prototype, they are not going to carry out all the testing. When they are going forward, because it will be sizing small. Okay, even the building also. We will have prototype in front of your office or laboratory. This is our building, this is kitchen, this is office room, this is like that, right? That is prototyping. When you are talking about quality assurance, after releasing the final part, either 3D printed part or the traditionally manufactured part, you have to carry out all the testing first. Excuse me.
So I'll move to this question. Muthu, so you have something to say, Muthu?
Guys, can I? Okay. Balaji, can I ask a question, please?
Why not?
Yeah.
Yes. See, Bharti, I'm going to echo the same question that Ramesh has asked in the questionnaire. In the sometime back, I came across this news article about ghost guns that are being America where you can just print a gun.
Okay.
So you can print right from Glocks to, right up to grenade launchers using a 3D printer. And right now there is this, First Amendment right that is being disputed, with which anybody can just, manufacture guns. All right.
Yeah.
Right now, in my sense and knowledge of 3D printing, there isn't any ethical code as such with which, a number should be, fed into the 3D printer. A code should be, fed into the 3D printer to actually put a part or a product.
Yeah.
Right?
Yes.
The design is just, converted into print.
Yes.
Future, is there any ethical code that is being debated in the background, so that whenever a part is being printed, it should have an approval code?
Yeah, I get it. See, this code will be definitely implemented. Now 3D printing in India, it's R&D stage only, not directly production. Small batch production is being used, otherwise still R&D only. Definitely this coding is required. Coding is also must. It's up even for 2-wheeler, 4-wheeler also. If you lost any part, using that code only you can identify the part in either Japan or Korea. They lost the code of the part, right? That there will be one number will be there. So that will be adopted in 3D printing. Since it is R&D stage, it's not yet implemented, but they'll start. Even the gun is 3D printed in CPET itself. We have replaced most of the wooden blocks, most of the metal parts into polymer. Like we are using polycarbonate for rifle in such a way that we have reduced the weight of 80%. If the gun weight is 5 kg means we have reduced to only 1 kg, like that. It's under production.
Okay. Reading Ramesh's question, is there a way in which the 3D printer will say, no, I won't print this part, this is banned? Is there a way the 3D printer will interact that way?
It's a really very good question. As I said, 3D printing, everything can be printed. Even, see, we can design anything and everything. But using traditional method, certain complicated method cannot be manufactured using traditional manufacturing method. But it is possible with 3D printing. What is not possible means a very thin material, like 0.01 thickness of material, or like using gas or using water. You cannot print. That's it. Otherwise, everything is possible. You can make it.
So I'm going to go with the next question.
The ethical problem there is, it is not what the 3D printer prints. This guys can make 3D printer itself.
I think, guys, it's too late in the game, because people have already printed guns and they are, they've used those guns.
They are developing their own 3D printers, Sampath. Where will you go and put the code there? Forget about printing from a guy where I purchased a 3D printer. I'm building my own 3D printer.
No, actually, no.
Guys, I love this discussion. Guys, hold on.
Balaji, I think Vegetarian raised her hand.
So Mini has raised.
Hi, Mini.
This debate is very interesting. I think we will continue after this. Mini, over to you.
Oh, okay. Hi, good morning, good evening, good afternoon, wherever you are. So I joined a bit late, so I still have a question, and I'm looking forward to the recorded version so I can view it fully. The question is, I saw, Barathi, you were drinking from a cup that was printed from the 3D printer, right?
Yes.
So my question is, maybe it's naive, but currently the same printer can be used for printing, right?
Yes.
But in this case, 3D printing, is it like a different printer to print each of those things? Like to print a gun, you have to have a mold or something, right? So
yes.
It's like a single printer can print all these things, so you would have something specific to each one.
Okay, that's a really good question. So it depends on the size of the product. If the printer is small one, I cannot print parts of gun, right? If the printer is bigger one, Then I can go for size matters, nozzle matters, and type of 3D printing matters. If suppose I have to print more thickness or metal also included or multi-material, then I have to prefer different type of printers. Using the same printer, I cannot print all materials, all parts. Not possible. That is why varieties are there. Types of 3D printers are there. I should know this printer is suitable for this. I will know that. Anyhow, catalog is being given. Using that, we can make it.
Thank you.
So answering Mini's question, what you're saying, Bharti, is today you can buy a printer and that printer comes with certain specification of materials that you can use. For that, you can only use those materials. If I want to print something else of a different size, different material, then it has to be a different printer. Am I right?
Exactly.
Right. So it's not that you have one 3D printer and you can print anything you want.
Yes.
Okay. So the next question that's coming in is, you can say whether we want to spend more time on this or we can move on. So what are the materials that we use for 3D printing? Is it plastic? Is a question that's come in. I think the presentation you had spoken adequately. Is there anything that you want to add here?
Plastic and metal also can be printed. As I said, tools can be developed using 3D printing, right? I don't need to go for machining, milling, drilling, not needed. Directly you print your tool for making molds.
Right.
Yeah. Let her answer, man. She is the expert in that.
Yeah, sure. Point taken. Is concerned for time, nothing else. Because I need to let her go by 8:30 because she is sitting alone in the office. So that's the only concern, right? So
thank you, thanks.
Point taken, Shiva. Then the next one is 3D printing good for bulk manufacturing and is it cost effective?
Actually, 3D printing as of now, it's not suitable for a larger volume of production. The smaller volume of production, no, it's suitable. Bulk volume of production, it will be expensive. When you talk about 1 lakh pieces, 2 lakhs pieces, when it crosses 50,000 and above, better you go for traditional manufacturing method as of now. Maybe later stages, they may change the system. As of now, larger volume of production, we cannot use 3D printing because it's expensive. It is possible, but expensive.
Right. And another question, Bharti, is this is from MMK. I think it's Muthukumar Mani, I think. Is it possible to do 3D printing using composite plus Kevlar? Cheapest 3D printer for toy making?
Yes, yes, of course. Of course, it is possible. Kevlar, you can use it. Composite, it's already there. Composite materials can be used for 3D printing. That's what polyjet. There is a type of 3D printer called polyjet. You can use that for composite material printing. For making toys, the best choice is 3D printer.
Right.
If I may very quickly interrupt, thanks, Barathi. Thanks for the wonderful session. I have to bail out now. Thank you very much for the informative things. And yeah, wish you all the best.
So nice of you. Thank you. Thanks.
So the other question is, how many types of 3D printers are currently available in the world?
In the world, I have not worked on that. As of now, 16 types are there. I have shown, I think, 12 types. 16 types are there. More are there. I have not worked on that. Maybe more than 20, 25 types are there. Right. Must be there. Yes.
And one other thing, next question is, where do we get 3D printers for food? Are they cheap or expensive?
Any 3D printer supply, see, FDM also, you change the material. Instead of using polymer wines, you can have this kind of food grade material and make your own chocolate, your own biscuit, customized biscuits. It's possible, yes. Only changing the material, that's all.
Right. And the next question, Bharti, is any examples for Inconel alloy 625 titanium 3D printing?
Yeah, Inconel, it is for making dies, right? Yeah, it is possible. You can have your tools and dies using metal printing. In the metal printing, they can use even titanium also. Titanium. The Inconel also, yes, it's possible. I have mentioned.
Hey, one thing, Bharti, in terms of the design before you get into a 3D printing,
Yes.
So what kind of a skill set is needed for people? Like, let's say I'm a SME, I wanted to start something across on.
All right, you should have.
Let's say trading.
Yeah. I'm getting your question. You should know to design the product. If you are comfortable with the Creo software or SolidWorks or NX or CATIA, it's enough. You design. If you don't know design, also no problem. Right? You hire one designer, like a fresher from mechanical engineering background or diploma holders. They will design whatever you give to the drawings. No, they will develop it. Then you can go for 3D printing. You can print. Even if there is a mistake, also it will print. But we should know that there is a mistake before going for 3D printing. Even assembly also directly printing. Yes, you can print it directly. But if you have design knowledge, it's better.
I had a question, Bharti.
Yeah.
You said that one of the weaknesses with 3D printing is it has only 80% of strength.
Yes.
So are you referring to if I'm using, say, for stainless steel raw material for 3D printing?
Yes.
If I prepare a product which is machine made as compared to 3D made, you're saying that same stainless steel, right? If I use,
I
think that this will still be 80% of the strength only.
Yes. That is
and that's
not
because of the thickness in the is that right?
Not thickness, sir. It's because 3D printed products are not printing like a big thick layers. It's layer by layer, and the layer thickness will be of like 2 mm. Depends. That's all. Layer by layer only. We are not constructing like block by block, right? It's due to that. And the layer is being when it is going to next layer, there will be adhesive. That is highly flammable. Okay, due to that only the strength of the product is 80% only comparing with the printing method. It's not affecting the thing. As I said, the chair, the metal chair or plastic chair, the same plastic chair what my children are using, I can also use that, right? It won't be a big effectiveness or like it's not a big matter.
Excellent. So that brings to all the questions that's there, Bharti. So I'm going to